Now we are going to see how to find the angle between a plane and line. Here we have a green plane pi and a blue line L, and we are trying to find the angle between them. So let me use another color. Basically what we consider the angle between a line and a plane is if we take over here the projection of the line on the plane. So that means we have this line to be perpendicular. This angle over here, theta, is the angle we are trying to find. I'm going to add a little bit of information to this picture we have here. For instance, let me get another color. This perpendicular, we can draw here the angle N that is perpendicular to the plane. And we want to also, with a different color, we want to also draw the vector that gives the direction of the line over here, the vector D. So if I continue the perpendicular line of the normal vector, over here we see that actually this angle we have over here that I'm drawing with sky blue and I'm calling phi, this is easy to find because we can find it as the angle between the vector N and the vector D. And if we are able to find that vector phi, then we can find theta, the angle between the line and the plane, because it's going to be given by the relationship that is theta is 90 degrees minus phi. So that's what we do. We find the angle phi between the vector N and the vector D. Let's see how this works in an example. So let's consider a plane pi, any equation of a plane. I'm just going to make it up. Let's say x plus y plus z is equal to 17. And we also need the equation of the line L. I'm going to write it in vector form. So I'm going to say that vector R is given by some point 0, 1, 2 on the line plus parameter t multiplied by the direction vector 3, 2, 1. So here, let's write that the normal vector to the plane is given by 1, 1, 1, and the vector on the direction of the line d is given by 3, 2, 1. So to find the angle phi between D and N, we are going to use the formula that says that the cosine of this angle is given by the dot product between the vectors divided by the product of the magnitudes of them. So the dot product between these vectors is going to be 1 times 3 plus 1 times 2 plus 1 times 1. So 3 plus 2 plus 1. And this we have to divide it by the magnitude of n, which is given by square root of 3, times the magnitude of d, which is given by 9 plus 4 plus 1, so square root of 14. So 6 divided by square root of 3 times square root of 14. So now we need to find what is the cosine inverse of 6 divided by 3 times 14, square root of all that. And we get that that's 22.2 degrees. So actually we need the angle that is 90 minus that, so 67.8 degrees. So now we can go back to our problem. We found with the calculator that phi is given by 22.2 degrees. Then this means that theta, which is actually the angle we are looking for, angle between the plane pi and the line L, is given by 90 degrees minus 5, so is 67.8 degrees.